Good day everyone. In this video, let us discuss the introduction to the fluid mechanics, but we will focus on the density of any substance. Now, no wonder the importance of the fluids. Fluids are very important in our life because take note that we drink them, we breathe them, we swim them, and the fluids also circulates our body and it controls the weather. Therefore, understanding on both nature and technology requires knowledge in mechanics of fluids. Now, what is fluids? Fluids is a substance that has no fixed shape and yields easily to external pressure. So, we cannot compute the volume exactly on the fluids, except that it requires container. Unlike solid, that there's a specific volume, but the fluids are not. Now there are two types of fluid. We have the gas and we have the liquid at the surface of the earth. So we have the third is the plasma, but we ignore that because we will focus only on the substance that can be found in the surface of the earth. Now the mechanics of fluids, there are two disciplines. We have the fluid statics, meaning the fluids at rest, and it studied the density, pressure, and buoyancy. So in this series of videos, we will have this topic only: density, pressure, and buoyancy. The buoyancy explains the Archimedes principles. And another is we have the fluid dynamics. So we will study the continuity equation and the Bernoulli's energy theorem. So in this video, let us focus on the density. Dynamics of fluids means the fluids now is in motion. So it requires the continuity equation and the Bernoulli energy theorem. Okay, so the density of matter. Now in the picture below, we observe that the cork floats into the water, and wood partially floats on the water, but the aluminum submerges into the water. What do you think? Why this happens? Okay. Another is the ship normally floats the seawater, but the needle submerges into the seawater. So, why it happens? What are the factors affecting this? Is it the weight of the object? Of course not. It should be the density that matters. And also as we go into the buoyancy, we can understand that why is it that body will floats. But in this case, we can explain why is it that the particle floats to another particle. Okay? So, what is density? By definition, in general meaning, the density is the amount of anything per unit volume. So, if we have the object, and if we divide it by its volume, we are actually measuring its density, the amount of that material per volume. So meaning if I divide the mass of the object by its volume, we call this as the mass density. In symbol, we use the Greek letter rho, corresponds for the density, mass density of substance. So therefore, follows that the density is mass over volume. So the density is directly proportional to the mass. The greater the mass, the greater the density. But it is inversely proportional to its volume. If you reduce the volume, maintaining the mass, then the density becomes greater and greater. Means the particle now is dense compared to the other. Okay, so take note that the unit of mass is kilogram in SI, and the unit of volume is cubic meter. Then it follows that the unit of mass density should be in what? Kilograms per cubic meter. That is the unit in SI. Okay. Now in CGS, which is the lower system of or unit of the MKS, the density, mass density is gram per cubic centimeter. And in the English system or British, it should be pound per cubic foot. Now, the density of water or rho sub W is 1,000 kilograms per cubic meter or 1 times 10 raised to 3. Take note that we should know the density of water because the water is the largest substance that exists in Earth. So the density of water is 1,000 kilogram per cubic meter. Anytime that we are solving, we can use this. So from the formula of the density, mass over volume, if we multiply the density by the acceleration, let us say due to gravity, then the result now becomes rho g is equal to mg over v. But take note that mg is the weight of the substance, which means that you are now dividing the weight of the substance by its volume. So that we call that as density, weight density of the substance. So therefore, the weight density of substance must be what? The weight of the substance divided by the volume of the substance. If you divide the mass by the volume, that is mass density. But if you divide the weight by its volume, we call that as weight density. So then it follows that the relationship between the weight density and the mass density, D, or the weight density, is equivalent to rho g, or the mass density, multiplied by the gravity. So D is rho g. Which means that if we transform the formula of the weight density, we can compute of the weight of the fluid or any substance. It is just equal to what? Rho g v. Meaning, if you don't have the mass, but you have the density and you have the volume, then the weight of the substance can be computed by rho g v. In our previous understanding in mechanics, that when we say weight, it is the product of the mass times the gravitational acceleration. Yes, it's true. Why? Because mass, remember, in relation to density, it is rho v. So meaning, when we say rho gv, it is the same as the mass times the acceleration. So there are some densities, known densities in many literatures, and there are just an example. So we have the materials and we have the densities. The unit is in kilogram per cubic meter. So for example, water. In table, the water is 1.00 times 10 raised to 3 kilograms per cubic meter, meaning it is 1,000 kilograms per cubic meter as the density of water. While the seawater, it has 1.03 times 10 raised to 3. So what does it mean? It means to say that the seawater is dense compared to water, fresh water. Because water is just 1 times 10 raised to 3, while the seawater is 1.03 times 10 raised to 3. Meaning that if you mix the two, the fresh water and the seawater, there must be the interface between the two substances. Why? Because they have of different densities. So the smaller the density, the smaller density will float into the higher density. So if you mix oil and water, then oil must have the less density, like ethanol. The ethanol is 0.81 times 10 raised to 3. So if you mix the ethanol with the fresh water, then it will float into the water. Why? Because the density is less than the density of water. So meaning the greater the density will be below to the smaller density. It is composed of layerings. So that's why Earth's surface we have the stone. Okay, then above are air, air, and we have the other particles which has less dense compared to stone, and we have the water and so on and so forth. Okay, so remember, air is at 1 atm and 20 degrees Celsius temperature. The density of air is 1.20 kilograms per cubic meter. Okay, and we have also the aluminum. So when we say aluminum, 2.7 times 10 raised to 3. And for the copper, remember the copper is material that used in our conductor, electrical wirings. Normally, it is made up of copper. So the density of that is 8.9 times 10 raised to 3. And also the mercury. Mercury, we understand this is a liquid metal. 13.6 times 10 raised to 3 kilograms per cubic meter. But the gold is much denser compared to mercury. It is 19.3 times 10 raised to 3. And the platinum is more dense compared to gold. Okay? So the greater the density, the smaller will float onto the greater amount of density. Okay, so another important, if we studied static fluid or fluid static, we should know what is specific gravity or relative density. So they are the same, no? Specific gravity or relative density. Now, relative density or RD, it's the same as the specific gravity, or in symbol is PGR, is the ratio of the density of the substance to the density of the given reference material. Which means that if we divide the density of that substance by the density of a reference material, then you are calculating the relative density or the specific gravity of that substance. So for example, suppose I want to know what is the specific gravity or its specific density of that substance, then all I need to do with respect to water, so then all you need to do is to divide the density of that substance, then divide the density of the substance divided by the density of oil. So doing that way, you are calculating the specific density of that substance with respect to the water. So our reference is the water. We are measuring the relationship, no, or the relationship of that density of the substance with respect to the water. Of course, we can use another reference, like our reference is seawater, for example. Remember, seawater is 1.03 times 10 raised to 3. So we can provide the specific of gravity of that substance relative to the seawater also, or any substance. So again, the density of substance divided by the density of the reference material in water, we call that as specific density. Specific gravity. By the way, this is specific gravity or relative density. So you can change this to specific gravity or SPGR. So SPGR of water. So what is the specific density of water with respect to water? It should be the density of water divided by density of water. So it means to say 1, because the value are the same. So 1 is the specific gravity of water with respect to water. But take note that we can also calculate the specific gravity of water with respect to, let us say, alcohol or mercury. But in this case, we are providing the specific gravity of water with respect to the water. Why? Again, it's very important to know the property of water. So we understand the specific gravity, the density of substance, okay, of a density of water, and now we also understand the specific gravity of water with respect to the water. So the specific gravity of water again is 1. So the meaning of this. Now in the table, we understand that take note that the water is 1 times 10 raised to 3. Meaning, if you want to calculate what is the specific gravity of that substance, just remove the 10 raised to 3. Why? Because take note, we divide 1 times 10 raised to 3 for the reference water density. density of water. So meaning, in that case, uh, removing the 10 raised to 3, the answer is 1. So that should be the specific gravity of water with respect to water, and that is 1. So what is the specific gravity of seawater with respect to water? The answer is 1.03, and so on. So therefore, if we ask what is the specific gravity of aluminum, remove the 10 raised to 3, that is 2.7. So again, we can easily find the specific gravity and take note the table provides the density of substance. So going back to this figure, so let's answer this. Why is it that the cork floats into the water? What will be the theoretical support on this? So since the cork floats into the water, then it signifies that the cork is less dense compared to water. So in other words, the density of the cork should be less than the density of water. Remember, the density of water is 1000. Another thing is we can explain that in terms of specific gravity. Because the cork floats into the water, then it follows that the specific gravity of cork should be less than 1. Okay, that's it. No? You can explain that in two ways, in density or specific gravity. Remember, the reference material is water with respect to water. So, the cork should be less than, the specific gravity of cork should be less than 1. Now, for the wood partially floats into the water. So, whether completely or partially float, then theoretically, the density of wood is less than the density of water. Meaning, the wood is less dense compared to water. In that case, not all wood, no, in that case only. So another thing is the specific gravity of wood is less than 1 also. Okay, so that's it. No? But take note that aluminum is completely submerged into the water. So it means to say that aluminum is dense compared to water, and it's very obvious. The aluminum is density is greater than the density of water, greater than 1000. It should be 1000 or more, or that is 2.7 times 10 raised to 3. So then it follows that the specific gravity of aluminum with respect to the water is also greater than 1. So these are the explanation of this problem. Okay, now for the ship and the needle problem, the ship will float into the seawater while the needle submerges into the water. So again, there are many ways to explain this, but in terms of density, because it floats into the water, then it follows that the ship has less density compared to the seawater. So it should be, the density of the ship should be less than 1000. Okay? Now take note that it is not the weight that causes the object to float. It is the density. Okay, yes, of course, the ship is much heavier compared to the needle, but take note, it has a large volume. So if you divide the mass of that ship by its volume, then the result is less than 1000. Meaning, the specific gravity of that ship should be less than 1. Not 1000 of the, it should be 1030 for the density of water. Okay, so that follows that the specific gravity of ship should be less than 1.03 because our reference material now is the sea water. Okay, so for the needle, because it submerges into the sea water, then the needle density should be greater than the density of seawater. Okay, the mass is less compared to the ship, but the volume is a very, very small. So the combination between the mass and volume, the mass now is greater than its volume. So then it follows that the density is now greater than the seawater. By the way, the 1.03, remember, is the it is the what? Density, a specific gravity of seawater with respect to the seawater. So the specific gravity of needle should be greater than that amount, 1.03. Okay, so the answer. By the way, we can also explain this by buoyant force. So our next videos coming will explain why the particle floats. We call it as buoyancy. Okay, so therefore, take note that the seawater is 1.03 times 10 raised to 3 as the density. Okay, now let's have the problem. Problem number. Jason claimed that that a piece of rectangular prism is gold material. It's a gold material. Now, you come up the dimensions of the material to be 3 centimeters and 2 centimeters. The 3 centimeters is the length, the 2 centimeters is the width, and the 1 centimeter is the height of the rectangular prism. Okay? And the weight after weighing is 116 grams. This is all about after measurement. So meaning you want to verify whether it is a gold or not. So the question now is the prism gold or not? Meaning, is it a gold or fake? So how to answer this problem? So since you have already gathered the data, the dimensions and its weight, then we can compute the density of that substance. Now take note that if that material is a gold, then the density should be what? Should be the density coming from the table. So remember the table, we understand that gold is 19.3 times 10 raised to 3. So this will be our reference. Meaning, compute the density of that material based on the physical dimensions, then compare it to the table. If the value is very close to that, or the difference is not significant, meaning you have to take the percent error, percent difference. Now, if the percent difference is greater than 10, then that material is not a gold. It is a fake, or it is not really a gold. But if the density is very close to 19.8, meaning the percent difference is less than 10, then we can call it as a gold material. Okay, so theoretically, solve for the density of that material. So mass over volume, the mass is 116 grams. But we need to convert that into SI. So convert that to kilograms. Now remember, in 1 gram, there are 10 raised to 3 kilograms. While the centimeter, 1 cm, is times 10 raised to negative 2. Or, the 3 centimeter can be converted into 0.03, while the 100 grams can be converted by multiplying the times 10 raised to negative 3. So, do the calculations. So, the 116 should be multiplied by 10 raised to 3. Why? Because it is a grams converted to kilograms. In 1 kilogram, there are 1,000 grams. So, meaning, the 1 gram is 10 raised to negative 3. And the 3 centimeters divided by 100, because in 1 meter, there are 100 centimeters. And in 1 centimeter, there is 10 raised to negative 2 meter. So, therefore, 0.03 times 0.02 times 0.01. Now, this result will be divided from the 116 times 10 raised to 3, negative 3 kilogram. And the answer is 19,333.33 kilogram per cubic meter. So, when you compare this, take the percent difference. Surely, this answer is very much less than 10. So, therefore, we can say that this is very close to 19.3 times 10 raised to 3 kilograms per cubic meter. Then, the answer should be, yes, it's a gold. It's not fake. Why? Because the calculated density is very close to the ideal one. That's it. Okay? Very easy. So, meaning, we are able to answer this problem because of the principle introduced by the density. So, very important to know the relationship of the density to its mass and its volume. Okay, for the problem number 2. the problem says that find the mass and weight of air. So you're asked to find the mass of the weight and air. That is at 20 degrees Celsius in a living room. No, in a living room, in a room. Remember that we did not see, no, we cannot see the air, but you are asked, what is the mass of that? How heavy is the air inside your room? Okay. Remember, we cannot see, but we can feel it. But it has a mass. So if you combine all the particles inside your room, what will be the total mass of that? Now remember that we don't know, no? We don't know where that particle located because we cannot see. So the dimension of the living room is 4 meter by 50 floor area, and the ceiling, the height, is 3 meters. So this is again a rectangular prism. By the way, forget this next question. So let's just focus on find the mass and find the weight. So ignore this question. So to answer this problem is to use the density formula. So density is mass over volume. Okay, next is we should know what is the density of air, because we are about to find the mass of the air, so we should have the data to use. So from the table, the density of air is 1.2 kilograms per cubic meter. So then this will be our density of air. So we have already the density of air, and we are interested to find the mass. So take the diagonal product of that. So diagonal product, mass is equal to density times the volume. So the density is 1.2, that's the density of air, multiplied by the volume of the room. Remember that the volume of the room contains air. So we can utilize the dimension of the room, and that will serve as our volume. So the density of the air multiplied by the volume of the room, the result should be the mass of the air. Okay? So all units are in SI already, so no need to convert. Then take note, when you notice here, the volume, meter times meters, cubic meter, so we can cancel that with the per cubic meter. So the result, the unit should be in kilogram, and it is the unit of mass. And the answer is 72. Okay? So in a 4 by 5 floor area of living room with a ceiling height of 3 meters, the standard room, the air molecules has a total mass of 72 kilograms. Take note, it's very heavy. It's more than 1 sack of rice, because 1 sack of rice is just 50 kilograms. And here comes the air inside your room is 72 kilograms. So imagine, it's very heavy. No? It's heavy actually. Okay. Now, what's the weight of the air inside this room? So take note that if we multiply by the gravity, no, of the density by the gravity, then it produces weight density. So then it follows that mg is weight. So therefore, we can solve for the weight, and it is rho GB. We discussed this in the previous slide. So the weight of the substance can be computed using the formula rho GB, aside from the mass times gravity. So since air, we have air is 1.2 times the gravitational acceleration, because we are at the surface of the earth, so 9.81 times the volume, the same volume, no? So the same density, the same volume, and we multiply it with g, and the result is 700 newtons. This is the weight of the, remember, the weight is the force that the earth exerts on that object. The mass, take note, is the quantitative measurement of inertia, and the mass is 72 kilograms, but the weight is 70 newtons. Now, if you use 72 to be the weight of the air, then call it as 72 kilogram force. So actually, the 1 sack of rice is 50 kilogram force. So again, the 72 kilogram force is much heavier than the 1 sack of rice, which is 50 kilograms. So these are the answers to the problem. We are able to calculate the mass of the air, even though we did not see them. So that's the power of theory. Okay? So, thank you for watching.